All right. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of tutorials. This is a place where you learn effortlessly. Now, in today's lesson, we continue with systems of equations. And basically, we are going to look at when we say a system of equation is consistent. Let me say consistent. And when do we say a system of equation is inconsistent? Consistent. Okay. So when do we say a system of equation is consistent, and when do we say the system of equations is inconsistent? By definition, consistency just means the system has a solution. Okay. And types of solutions that exist or that are there: one, we have a unique solution. Okay, a unique solution, this is where maybe all values of, if we have x, y, and z in the variables, for instance, where x is equals to a, y is equals to b, z is equals to c. This is a unique solution where each of the variables have a unique value. Okay, that is a unique solution. Different values, a unique value. Okay, from there we have, or where these are any other numbers, 2, 3, 4, 5, 7, 8, 9, 10, whatever value. Then we have infinitely many solutions, infinitely many. Infinitely many solutions. Okay, this is where we talk about the issue of free variables. I'm going to explain what these are. Free variables. Okay, so but basically free variables are variables that we introduce for that can take any number from 0 to infinity, whatever number that is. Okay, so those are free variables. Then we also have a trivial solution. So this is trivial solution. Okay, so this is for most likely, or let me say more specifically, homogeneous equations. Okay, homogeneous equations. This is where the variables are all equal and they are all equal to 0. That is, x is equals to y is equals to z is equals to w, whatever variables that we have, and all these are equal to 0. So that is a trivial solution. In the same line, there is non-trivial solution for homogeneous. Non-trivial, so non-trivial. Non-trivial for homogeneous again. Let me tie it to homogeneous. For homogeneous, non-trivial solution basically means the system has infinitely many solutions. Okay, so that is, these are types of solutions. So when a system of equation is consistent, it basically means it has a solution, and we can check by solving if the solution is unique, it has infinitely many solutions. And if we're looking at homogeneous systems of equations, which are basically equations in the form ax equal to 0, where all the equations are equal to 0, the constants at the end of the equations are equal to 0. This system has a trivial solution when x is equals to y equals to z is equals to 0. So this is a simple solution because all the variables, all the equations are equal to 0. If you replace x equals to y equals to z equals to 0, the equation will be satisfied. So that is why it's called a trivial solution. For non-trivial solution, this is where we will get an infinitely many solution case. That is for homogeneous. Then now when it comes to inconsistency, inconsistency is basically no solution when a system of equation has no solution. Okay, so when a system of equation has no solution, we conclude that it is inconsistent. Okay, so that is basically what you should know about consistency and inconsistency. Now, how do you tell that a system of equation is inconsistent? I'm going to give things that you should not. So for instance, if you have a matrix, let's say A, B, C, 0, 2, 1, let's say 0, 0, F, then you have A, B, C. Okay. Suppose you have an upper triangular matrix and you have reduced this matrix to echelon form, as we've learned using Gauss elimination. So suppose you've used Gauss elimination and you reach this stage where you have an upper triangular matrix. Now, what you should note is the last part of the matrix. Make sure you make it an upper triangular where you have the values decreasing, where the first row has more terms than the second row, and so on and so forth. So when you have an upper triangular matrix like that, what you should consider is the last row here. Okay, and basically these two values that are here. Okay, these two values that are here. Okay, so now if you have zeros throughout, that is 0, 0, and F here is equal to 0, and C here is equal to 0. So you have 0 and a bar there and 0 like that. For this case, we conclude that the system has infinitely many solutions. We conclude that the system has infinitely many solutions, and we need to find those solutions. So we need to find the solutions. Okay, we need to find those solutions. Okay, then now we suppose in the last row, use yellow here, you have 0, 0, 0, then any other number here. So F part, which is this, is equal to 0, and C is not equal to 0. Okay, you have something like that, 0, 0 up to the block there, and any other number here. Here the system has no solution. Okay, has no solution. And basically here it's because suppose we have this, so we're going to have 0z. If we have z there, is equals to C, for instance. 0z is equals to C, or yeah, 0z is equals to C. Then we can divide both sides by 0 like that. Then z will be equals to C over 0. If C is 7, for instance, what is 7 over 0? This is undefined. Okay, so that is undefined. So that is why we conclude the system has no solution. So you just conclude like that. So the system has no solution. So if you have, so these will be our guides. So the last row will be our guides, and we'll be looking at that. Then the last one that we can talk about is when you have a unique solution. So a unique solution is having 0, 0 here. You have a number there and another number there. So you have F, which is equals to any other number that is not equal to 0, and C should also not be equal to 0. So if f is not equal to 0 and c is not equal to 0, we conclude that the system has unique solution. Okay, unique solution. So those are the two cases, or the three cases rather. So infinitely many, no solution, and unique solution. Okay. Then now let's look at a case that will help us understand, or let me, even before I go to that example, suppose I want us to understand the term free variables. Okay, so the term free variables, this is a term that you'll come across, especially when your system has infinitely many solutions. Okay, infinitely many solutions. Okay, so you need to know what a free variable is. So a free variable is basically a value that will assign to a particular value. Okay, and this value can take any number. Okay, any number from 0 to any number that we want. Okay, to infinity basically, because they are infinite. Okay, so suppose we have a system like, let's say 2x plus 3y minus 7z, and this is equals to 4, suppose. Then we have 3y plus 2z equal to 5. Let me say you know how to arrange already. So let me say 3y minus 7z is equals to 4. Okay, is equals to 4. Then we have 9y minus 14z is equals to 8. Suppose you have this. So the first thing that you do is you arrange the values and their likes. Then from here, you convert this into a block matrix. So we have 2, 3, negative 7, 4. Then we have on the y, we have, on the x, we have 0 here in the second equation. We have 3 on the y, negative 7, and 4. Then we have 9 on the x, we have 0. On the y, we have 9. We have negative 14, and we have 8 here. Okay, so remember, these rows are representing, or the columns are representing x, y, and z. So all the terms in the given what's this, in the given column are x, in the given column are y, and in the given column is z. So here we'll reduce this matrix to an upper triangular matrix, so we need to make a 0 there. So we'll just say row 3 changes to, let's say, 3 row, or let's say row 3 minus 3 row 2. So row 1 will remain unchanged. We're going to have 2, 3, negative 7, and the 4 here. Then we have 0, 3, negative 7, and the 4. Then we're going to have 0 here. So 0, then row 3, that is 9 minus 3, that will be 0. Row 3, that is 14 minus, okay, 14 minus 3 times 7. Let me just make a little bit of an adjustment here. Sorry. So instead of 14 here, let me just make a bit of an adjustment so that I bring the question as I want it. So let's say, and here, let me just make an adjustment here. So let's say this was what? Okay, so this is 21. Suppose this is 21 and this is 12. So sorry for that. So let's say this is also like this. So that is 21 and that is 12. Okay, so suppose we have this, we've converted it to this, and now we need to make an upper triangular matrix. We need a 0 here. So we said row 3 should be equal to row 3 minus 3 row 2. Okay, so yeah. So now here we're going to have row 3 that is negative 21, and negative 3 times that will be positive 21. So this will give us a 0 here as well. Then here we're going to have 12 minus 12, that will also be a 0 here. Okay, now when you look at this, the last row here, we have 0, 0, 0 everywhere. So we know that the system has infinitely many solutions. Many solutions. Okay, the system has infinitely many solutions, but we need to find those solutions. Okay, now here we know that the first column here is representing x, this is representing y, and this is representing z. Now when you check the major diagonal here, our main concept or our main aim is looking at the major diagonal here. When you check our major diagonal here, the 0 is on the z. Okay, the 0 is on the z. So since the 0 is on the z, we let z equals to any letter of our choice, maybe t. Okay, so z is what we call a free variable. Okay, and when you back substitute, this will be the first equation will be what? 2x plus 3y minus 7z equals to 4. And here we're going to have 0x, so it just 3y minus 7z is equals to 4. And we're going to have here, we're going to have z is equals to t. So z is equals to t. Okay, so that is the last term there. So now here it's just substituting. So z, you replace t here, it will be 3y minus 7t, where there is z here, then t there, then we say equals to 4. So we make y subject here, it will be 3y is equals to 4 plus 7t, we say over 3 over 3. Y is equals to 4 plus 7t over 3. We found y, we'll find, so you replace here and here, that will be your x. So you found y using this, you replace there, so it will be 2x plus 3y, which is a 4 plus 7t over 3, minus 7 times z, which is just t, is equals to 4. And you simplify, you make x subject of a formula, so that those will be your values. Okay, so that this is the first case of a free variable. Okay, let's look at a second case. So a second case is where you have more variables than the number of equations. So I'll just put a simple, you say x plus y plus z plus w, and we have let's say z plus w, then we have, okay, we have z. Okay, let's have w here. Okay, and this equals to 0, this is equals to 4, this is equals to, yeah. Okay, so this is equals to 5. So suppose you have that, okay? So first of all, you need to make sure they are arranged well and so on. Then you convert them into a block matrix. So for the first one, we have x, which is just the coefficient. We get the coefficient, which is 1. The coefficient of y, which is 1 as well. The coefficient of z, that is 1. The coefficient of w, that is 1. So 1, 1, and 1, then blocked with 0 here. Here, there is no x, so that is 0. There is no y, that is 0. We have z, which is coefficient 1, w coefficient 1. We have 4 here. Then here we have 0, 0, 0, 5. I mean 0, 0, 1, and 5. 1 and 5. Okay, so we have this matrix. So is this an upper triangular matrix? Yes, it is. So we have values like that. Now here you need to identify the free variable. This column is for x, this is y, this is z, and that is w. Okay, now you need to check. Okay, you need to check if the value has a leading element. Okay, the leading element, remember, is in the major diagonal. So this is supposed the major diagonal, that is, it takes on values like that. Okay, we should check, does the element have a leading element? Okay, so I think the best way that you can do this is you check Z here has a leading element. Okay, Z has a leading element and W has a leading element, but for Y there is no leading element. So a leading element is the first non-zero element in a row. So here, for when we just check in this row, we reach our X here. X is has a leading element 1. Okay, when we check here, when we go in a row, the first leading element we find is on the Z. So Z has a leading element 1. When we check in this row, the first leading element that we find is for W. So W has a leading element. So Y does not have a leading element. If it does not have a leading element, then it is a free variable. So anything that does not have a leading element, it is a free variable. So we let Y equals to T. So Y is a free variable because it does not have a leading element. That is what you should check for. So I'll give an exercise. So I've already given an example on how to work out that. So you let y equals to t, then you back substitute and start solving. Okay. Then now suppose you have this example here. I'll give another example here. So we have 1, 2, 3, 4, then blocked with 0 here. We have 0, 0, 1, 2, then we have 0, 0, 0, 0, 0, 0, like that. Okay. Suppose we have that and we have x, y, z, w, like that. And these are the solutions. So we take the leading elements. Okay, so this column is for x, this column is for y, and that column is for z, and so on and so on. So the leading elements are the first non-zero element in a row. So here, the first one, we see that x has a leading element, which is 1. So this is after we've simplified and we have made an upper triangular matrix. So the first leading element in this row is a 1. So x has a leading element. The second leading element here is a 1, which belongs to z. So z has a leading element. W has no leading element, so same applies to y. Okay, so y and w do not have leading elements. So these will be our free variables. Okay, free variables. So free variables are y and w. So we let y be any letter of our choice, y equals to t, and w equals to any letter of our choice, b. Okay, then we'll do our back substitution. So the first row will be x plus 2y plus 3z plus 4w equals to 0. The second one is just z plus 2w equals to 0. Then we have y equals to t and w equals to b. Okay, so we just replace to find the z. We just say z plus 2w. W is b equals to 0. So z will be equals to negative 2b. Okay, we have z, we have y, we have z, we have w. We can find x. So we say x plus 2y, which is t, plus 3z, which is negative 2b, plus 4w, which is 6, or which is b, sorry. No, this is b, and this is equal to 0. So you just make x subject of a formula, and that will be your answer. So basically, x will be equals to x will be equal to negative 2t. Then these will add up. This is 4b and 6. So when simplified, this will be negative 2. Then when you process the equal sign, it will be positive 2b. Okay, and that is your values. That is x is equals to this, z is equals to this, y equals to this, and that is equals to this. So that is how you identify the free variables, and you simply work out like that. Okay, and remember the key here is this. So these variables can take any number. They can take 1, they can take 2, and it will still have a solution. So this is why we say this system has infinitely many solutions. So t and b in this case can be any real numbers. So, but we just write them generally as t and b, so that we show that they have infinitely many possibilities. Now, I'm just going to give you a few questions. Okay, solve the following. Equations. Okay, it's a system of equations. Okay, solve the following system of equations. So suppose you have, I'll give 2x plus 3y plus 4z plus 5w equals to 7. Z is equals to 4. Okay. Y plus z is equals to 5. Okay, that is the first one. The second one, we have 2x plus 3y. I'm just giving simple. Let me change. Okay, let's say 5y plus 3z plus 4w equals to 3. We have 10y plus 8w plus 6z is equals to 5. Then we have 2y plus 3x plus z is equals to 13. Okay, so this, let me just add one more. Let me just add one more equation. Yeah, so we have this. Then we have x plus y plus z equals to 0. We have 4x plus 3. We just say 4x plus 4y plus 4z is equals to 0. We have 3x plus 3y plus 3z equals to 0. So I want you to solve these three questions, and I'll be waiting for your answers. So you're going to solve these three simple equations, and I'll be waiting for your submission. Have a great evening. For any questions, you can reach out, and we'll see how we move on from there.